Hello friends, welcome to Rajavali Education channel. In this video, we are going to see AC generator or single phase AC generator. It consists of principle, construction, working principle and a graph. First we see the principle. The principle involved in this AC generator is it works on the principle of electromagnetic induction. The relative motion between a conductor and a magnetic field changes the magnetic flux linked with the conductor, which in turn induces an EMF. The magnitude of the induced EMF is given by Faraday's law of electromagnetic induction and its direction by Fleming's right-hand rule. Next we see the construction part. This is the PQRS rectangular coil. The ends of the PQ is connected to the slip ring R1. The inner portion of the slip ring is made insulated. The ends of the RS is connected to slip ring R2. Here also the inner portion of the R2 is made insulated. The two conducting stationary brushes B1 and B2 are kept pressed separately on the rings R1 and R2 respectively. The outer ends of the two brushes are connected to the galvanometer to show the flow of current in the given external circuit. This PQRS rectangular coil portion is placed in between the two poles of the permanent magnet. Now the construction part of AC generator is over. Next we see the working principle. When the coil is rotated through this axle by an external force, in this uniform magnetic field, magnetic flux will be changed so that in this PQRS coil, EMF is produced. The direction of the EMF can be identified by using Fleming's right-hand rule. To identify the direction of the current, we should know what is a right-hand thumb rule. For that, stretch out thumb, forefinger and middle finger of your right hand so they are perpendicular to each other as shown in this diagram. If the forefinger indicates the direction of the magnetic field and the thumb shows the direction of the motion of the conductor, then the middle finger will show the direction of induced current. This simple rule is called Fleming's right-hand rule. This is the initial position of the AC generator. Here, magnetic field direction is perpendicular to this coil. So, time angle is 0 because this is initial position. Okay. When time angle is 0, magnetic flux is 0. So that EMF will be 0. Next, we have to rotate this PQRS coil up to 90 degree by an external source through this axle. Okay. During this 90 degree rotation, flux will be changed so that EMF will be produced. The direction of the EMF can be identified by using Fleming's right-hand rule. For that, this is for a PQ part of coil will come up and SR part of coil will come down during this 90 degree rotation. So we have to keep our right hand thumb to upward direction, and for this SR portion it has to point downward direction. Next we have to see the middle finger to find out the induced current direction. So for PQ part it is inward direction, for SR part it is outward direction. So the current flows along PQ and will come out along SR part. So the direction of the current is along PQRS during 90 degree rotation. So we have to put a positive sign here and a negative sign here because PQ part is attached to B1, that is ring 1, and SR part is attached to ring 2. So current flows along PQRS. So it current flows from positive terminal to negative terminal. So we have to put positive sign here and a negative sign here. Here you can see the rotation of the coil through 90 degree. During this rotation, EMF is increased. Next, the coil has to rotate from 90 degree to 180 degree by an external source. So during this rotation, EMF will be changed. The direction of the EMF can be identified by using again Fleming's right-hand rule. So during this rotation, PQ part will come up so that thumb points upward direction and SR part will come down. So thumb points downward direction. This is the magnetic field direction. So the forefinger points from left to right. From the middle finger direction, we can find out the direction of the EMF. For PQ part, it is inward direction and the SR part, it is outward direction. So the current, that is EMF, flows along PQ or S. So here we can put positive sign here and a negative sign here. This is the rotation of the coil from 90 degree to 180 degree. At 180 degree, the EMF becomes 0 because coil is perpendicular to magnetic field direction. Next, the coil has to rotate from 180 degree to 270 degree. During this rotation, EMF will be changed and direction of the EMF again can be identified by using Fleming's right-hand thumb rule. During this rotation, RS part will come up so that thumb points upward direction and the PQ part will come down so the thumb points downward direction. So this is the magnetic field direction, that is north pole to south pole. So the middle finger for RS part, it points inward direction. For PQ part, the middle finger points outward direction. So the EMF flows along SRQP. So the induced current direction is SRQP. So we can put positive sign at B2 and a negative sign at B1. Here you can see the rotation of the coil from 180 degree to 270 degree. So at 270 degree, the EMF is maximum because the coil is parallel to magnetic field direction. Next, the coil has to rotate from 270 degree to 360 degree, that is our original position. So during this rotation, EMF will be changed and the direction of the current can be identified by using again Fleming's right hand thumb rule. Okay. So during this rotation, SR part will come up, so the thumb points upward direction and the PQ part will go down, so thumb points downward direction. This is the magnetic field direction. So from the middle finger direction, we can identify the direction of the EMF or induced current. For SR part, it is inward direction and PQ part, it is outward direction. So the current flows along SRQP. So B2 brush becomes positive terminal and B1 brush becomes negative terminal. Here you can see the rotation of coil from 270 degree to 360 degree. At 360 degree, EMF becomes 0. Next, we see the theory part. Constant angular speed is equal to omega. Theta is the angle between magnetic field vector and area vector of the coil. At any instant t, theta is equal to omega t. At rest, that is t is equal to 0, theta is equal to 0. We know that magnetic flux value pi b is equal to Ba cos theta. Substituting this theta value in this equation, we get pi b is equal to Ba cos omega t. If the coil has n number of turns, we get pi b is equal to n into Ba cos omega t. According to Faraday's and Lenz's law, EMF value is equal to minus d by dt of n pi b. Substituting magnetic flux value, we get this one. And n, b, a values are constant. We take a derivative of cos omega t. So we get E is equal to minus n, b, a d by dt of cos omega t. Derivative of cos omega t is equal to minus sin omega t and derivative of omega t is equal to omega. So EMF is equal to minus NBA into minus sine omega t into omega. So minus into minus plus, we get EMF is equal to N into B into A into omega sine omega t. EMF value, when theta is equal to 0, EMF value is 0. When theta is equal to 180 degree, again EMF value is 0. Again at 360 degree, theta value is 0, so EMF value is 0. But when theta is equal to 90 degree, we get EMF value as NVA omega, since sine 90 is equal to 1. At the same time, when theta is equal to 270 degree, we get minus NVA omega. So EMF value is maximum at these two stages, at 90 degree and 270 degree. But at 270 degree, it has negative value. At these two stages, that is at 90 degree and at 270 degree, the EMF value shows maximum peak. So this NBA omega, we can consider E naught value. So E is equal to E naught sine omega t. Graph is plotted between EMF and the time angle. 0 is the initial position. At 0 time angle, EMF is 0. At 90 degree, EMF gets maximum value. When it is rotated from 90 to 180 degree, EMF is decreased. At 180 degree, EMF becomes 0. During this 180 to 270 degree rotation, EMF is increased, but the direction is reversed. At 270 degree, EMF is maximum value, but the direction sign is negative side. At 360 degree, EMF gets 0. So from this graph, we can say the polarity of the EMF is changed. That is from positive EMF to negative EMF. So that we can say the EMF produced is alternating EMF and the current is alternate current.